Have you ever wondered how RTD sensor elements work? These nifty little devices are key players in the temperature measurement field, and their functionality is based on a simple yet profound principle. You see, RTD, or resistance temperature detectors, measure temperature by correlating the resistance of the RTD element with temperature. These resistance elements, the heart of an RTD, are often delicate, requiring protection and shielding. Their readings are typically measured in ohms, the unit for electrical resistance. Various metals, each with their own unique resistance measurements for different temperature ranges, are used as resistance elements. The most common element is platinum, but others such as copper, nickel, tungsten, Balco, and even iridium are also used. Each of these metals brings its own set of characteristics to the table, influencing the performance, range, and accuracy of the RTD sensor they're part of. Intrigued? Let's dive deeper and look at the different types of RTD sensor elements. First up, we have platinum RTD sensor elements. These are made of pure platinum wire and are known for their positive temperature coefficient. What sets platinum elements apart is their linear and long-term stability, making them incredibly accurate sensors for industrial applications. This stability, coupled with a wide temperature range from -200 to 850 degrees Celsius, makes platinum RTD elements a go-to choice for many. In addition, platinum elements can be paired with copper wire extension leads, further broadening their applicability. So, whether you're monitoring the temperature in an industrial furnace or a high-precision lab environment, platinum RTD sensor elements can deliver the accuracy and stability you need. However, it's worth mentioning that while platinum elements are highly effective, they are not the only game in town. As we'll see in the next segment, there are other types of RTD sensor elements that might better suit your specific needs. Platinum elements, while effective, are not the only option. Next, let's explore nickel and copper sensor elements. Nickel elements have a limited temperature range, becoming non-linear over 300 degrees Celsius. This non-linearity requires error corrections, complicating temperature processing. Despite their good corrosion resistance and lower cost compared to platinum RTDs, nickel elements age swiftly, losing accuracy. Now, let's turn to copper. Copper elements boast good linearity in relation to temperature change but require a longer element due to their low resistivity forces. However, copper's propensity to oxidize restricts its use to temperatures under 150 degrees Celsius. While copper RTDs are less expensive and ideal for winding measurements for motors, generators, and turbines, they quickly lose their linearity and drift. So, while nickel and copper have their uses and advantages such as cost-effectiveness and good linearity, they are not without drawbacks. Their limitations in temperature range and stability mean they are not suitable for all applications. Now, let's consider Balco and tungsten sensor elements. Balco is an annealed resistance alloy made up of 70% nickel and 30% iron. This composition allows a Balco 500 ohm sensor to offer relatively linear resistance within a temperature range of -40 to 116 degrees Celsius. It has thermal conductivity on par with nickel, but boasts double the resistivity. Balco RTD sensors are also lauded for their strong mechanical properties and moderate corrosion resistance, not to mention their affordability. On the other hand, we have tungsten. Tungsten's standout characteristic is its high resistivity, making it fitting for high-temperature applications. However, it's worth noting that tungsten is brittle and can be challenging to work with due to its shape. Despite their unique properties, Balco and tungsten are not always the first choice, but it's their distinctive characteristics that make them invaluable in certain applications. So, what have we learned about RTD sensor elements? We've delved into the fascinating world of platinum, nickel, copper, Balco, and tungsten RTD sensor elements. Each unique in their own way, they serve as the backbone of temperature measurement in various industrial applications. Platinum, with its positive temperature coefficient, offers long-term stability and accuracy, making it a preferred choice for wide temperature ranges. Nickel, despite its limitations over 300 degrees Celsius, is favored for its corrosion resistance and cost-effectiveness. Copper, with its strong linearity and cost advantages, is primarily used in non-oxidizing environments. Balco, a mix of nickel and iron, boasts high resistance, linearity, and some corrosion resistance, making it an affordable choice. Lastly, tungsten, with its high resistivity, is ideal for high-temperature applications, despite its brittleness. Each of these elements has its strengths and weaknesses, and their suitability largely depends on the specific requirements of the application. Remember, the best RTD sensor element largely depends on your specific application needs.